Yeah, hello all. So is my screen visible?
Yeah, sure.
Yeah, and my recording is also on, right? Yeah. Okay. Yeah. So welcome to another session on CTCI and SD skills CTCI. So today we'll be discussing the couple of problems what were left over for the last session. This were about the bit manipulation. So the first problem will be like given a positive integer, print the next smallest and the next largest number that have the same number of 1 bits in their binary representation. Okay, so what does that mean? As like if you have any, okay, I'll just take an example. So a similar example, what they have here, maybe if you have some bits like this, right? Okay, and then I have another. Okay, so this will be something like okay, let me take a smaller one instead of that. 0 0 0 0. So if I have a bit of 6, right, so the value is 6, then I need to actually form its next greater element. So what will be the 6th next greater element will be something like 1 0 0 1, I believe. Yeah, right. So this is 5. No, this is 9, right? So I'm taking 6, and then the next greater element of 6 with having
Zero
the
one one.
same bits. I'm
Eight, it
sorry.
should be. Eight, I think. Eight should work. One triple. No, no, no. Eight.
Yeah. See, we have this 6, okay, and the bits which are set inside they are 2, right?
Hmm.
Okay, so we want the next higher number, which will be, in this case, it
Nine.
is 9, okay,
Hmm.
and the bits are also same, right?
Yeah.
So even if you take any number after that, like if you have 7, 7 will have 3 bits, 8 will have single bit, and 9 will be the next one which has 2 bits.
Two bits.
Okay, so this is the next one, next highest. And then if you want to print the previous one, okay, so in that case, what we have to do is like, uh,
Three.
yeah, 3,
0011.
yeah,
Five will
0011,
give.
yeah. So it will be 3, right? So 3 and it will have 2 bits, right?
Five should also work, right?
Oh, yeah. Yeah, I'm
Hmm.
sorry. Yeah, 5 is the best one, right? So 5 is
Yeah.
the, yeah. So if you look for, so the way it is done here is if you look at this bits, right? So if you count the number of 0 bits at the trailing 0 bits, it is 1, and then the after that we have a set of 1 bits which are 2. Okay, so what we have to do for the next one, we just set the one which is after the first block of all the ones. Okay, just set that one. So now if we have set 1 means we have to reset one more bit, right? So out of these 2 bit, we reset one of them and push all of whatever is remaining to the end. So then it becomes the next highest. And if you want to find anything which is the previous number, which is lesser than 6, in that case, what we do is we just set the first one bit. No, okay. So in this case, what we need to do is we need to find this guy. And okay, let us go through this algorithm so things will be clear. Okay. So at least for the brute force would be you just count the ones, okay, in n, and then increment or decrement till we get the ones are the same, right? So that is what it says. Now, there are two approaches what they have discussed in this book. One is the bit manipulation. Okay, so for the bit manipulation, he says if we get 2-bit locations, I and j, right? So if we change 1 to 0, okay, and I at I, and for j we change 0 to 1, and provided I is greater than j. So then what we'll get a number which will decrease, okay, and we'll have if we do it the other way, it will be the opposite of it, right? So now if we have this example, what they're going to, very big example. In this case, if you look at the bit representation, what they are shown here. So this is C0. C0 means all the bits of 0, the first block of 0 bits. Here we have 2, 0, 0, right? So therefore C0 is 2. And then we have 1, 2, 3, 4, 5. So therefore C1 is 5. So right now we are only interested in the last two blocks of zeros and ones. Okay. So therefore it is like C0 is 2 and C1 is 5. Okay. And then what we need to do is we have to flip the rightmost non-trailing 0. So the rightmost non-trailing 0 in this case, okay, I'll just annotate here. So this rightmost non-trailing 0 in this case will be this one, right? Okay. So if we actually set this bit, okay, as we set it over here, so now we have added one bit, right? So we need to reduce one more bit from the right hand side. Okay, so what it says is first you actually set one of this bit, okay, and then you clear all the bits to its right. Okay, so he has cleared everything now. And so we now know, like we already had 5 bits earlier and we have set 1 bit. So we are remaining with 4 bits, right? So if you look at here, what they have done is they have added all the 4 bits to the very end of to the very right side. Okay. So then we get a number which is actually the next greater one, right? So to do that, so what we need to do is it says like P is equal to C0 plus C1, and that is what is 7. Okay, so this is the 7th here, which is at the 7th position because we have 2 and 5 will be 7. So you set bit at 7th position to 1. And the way you can do is you can take an A mask. Okay, sorry, this is an A variable. And then you take P, then you shift it to, then you left shift it, and then separate by 1. Okay, and uh, and then you actually and it with the inverted one, correct? So in this case, if we do 7, so we have 1, 2, 3, 4, 5, 6, 7 bits, right? So we have almost 7 bits, and then what we are doing is we are masking all of them, right? And then when we mask them, then we OR it with -1 here. Okay, so if we take 7, so let us do that. So 0, 1, 2, 3, 4, and then we have 1, 2, 3, 4, right? So it is like, okay, so what will be the number here? Okay, so 0x, and this will be 8, 80 hexadecimal, right? So, okay, so here 0x hexadecimal will be 0x 80, and then if you have this will be 7f, right? So if you have 7f and then you mask it with okay, so then when you all zeros followed by p1s, right? And then I'm setting this to 1, a will be 1, I subtract this 7f, and then if I do it the reverse of this, this will be okay, so all will be 1 1 1 before that, so we'll have 0x 80, right? Yeah, so this is the one I have, and then if I actually mask my n, okay, whatever my n was in this case, it was 1 2 3 4, right? And then 48, right? So 48 if I mask with, and am I doing something wrong in this case? Okay, 7 if I do this, okay, and then I get mask of it. Okay, so let me actually go to the example what I have coded here. Okay,
Yeah.
so that will give an explanation here. I'm sorry for that. So Okay, so in this case, if you see here, if I get a next element here, so first what we do is actually whenever we get an element and we have to count the number of zeros and ones, right?
Your screen is not visible.
Oh, it's not zero, sorry. Okay, yeah, it's visible now, right? Okay.
Not visible.
So this is the get next one, right? So first I take this number n, and then I need to find 0 and 1. So I just go to while loop, okay, and then I look for the first zeroth element, and then I keep on incrementing the 0. So I'm just counting zeros and 1 in this case, right? So my p will be something like this, okay. In the case what we were having here, it was okay. So my c0 was 2 and this was 5. Okay, it was 7, right? So when I come here, so yeah, this is edge case where it says when my p is equal to 31, it means it is the very last bit. And if p is equal to 0, I can't do anything, right? So if all my numbers are zeros, and if my number, the sign bit is set to 1, okay, so it is the highest number, I can't do anything. So the first thing what I have to do here, and that is what we missed there, is like when I have this number n, I actually need to or it with p. Okay, first I have to do that, and therefore whatever the seventh bit, actually I'll be setting it here. Okay, so this will actually set the seventh bit. Okay, and then when I come here, I actually need to do find the mask. So if I do this 7, so what I'm going to get in that case will be 7f, right? So that is what I was getting, 0x 7f. So when I get this 7f, and then already I have set that seventh bit also, okay, and then if I or this C1. So this is the second part. First, actually, I'm setting the one which is to the very highest one, and then I'm clearing all the bits to its right side. So this 7f actually, if I invert this one, right? So I'll be clearing all the ones which are to the right side. So in our case, the word was something like this, right? Uh, okay, so if it is 1, 2, 3, so we had this one, right? So if the hexadecimal representation of this one, so I had this as first one was C, okay, and then this was 3, okay, this was 1, 2, 3. Oh, this was 7, sorry, this was 7, okay, and before that, so I had 6, so this was 6, and then this was 3. Okay, so this was my hexadecimal representation for that number. So in that case, what I do is I set the seventh bit, which is just before this. So that seventh bit when I set, so this number becomes 0x uh, 3, 6, and then this will become FC. Okay, so that is what it sets the seventh bit. Okay, so this is the seventh bit, right? So then I come here and then I actually clear all the bits after that. So this will be 0x 3, 6, and this is the 8, and then I clear all of them. So therefore it becomes 8, 0. Okay, and then what I need to do is, so whatever the remaining 1 bits are, in this case we have C1 which is equal to 5, right? So 5 minus 1 will be 4. Okay, so all the 4 bits, if I actually shift by 1 and then or it to here, okay, so then if I actually shift all of this to here, so what I'm doing is actually I'm forming another mask of 4, 0x 04, right? So when I form a mask of 0x4, so I just shift it to 4. In that case, it will be 0, 0, 1, 2, 3, 4. It will be the 16th bit I'll be setting, right? So it will be 1, 0. And then I was subtract with 1. Okay, so what I'm going to do here in this case will be 0x 0 and 0, and then this will be f, right? So then if I or this with this number, okay, so I'll be getting the number like this: 0x368f, right? So this will be my final output. And if I count the number of ones here, and these ones, they should be the same. Okay. So the example what I was showing there, I'll just quickly go there so it might be more clear again. Okay. Okay. Oh, again came back here. Sorry. So I was supposed to go to my OneNote. Yeah. So in this case, what I'm doing, okay, if you look at here, so the first when I'm sitting at 1 over here in this case, okay, so I need to set that to 1, and then so this is what I'm doing, 7f here, right? And then I'm actually clearing all the bits to the right side of it. Okay, and then I do a mask of that. And then here, then after I'm done with that, when I'm setting all of these to zeros, so in this case, I need to set all these 4 bits. These are the 4 bits, right? Okay,
Okay.
so these 4 bits, right? So what I do is, so how these 4 bits come in, because my C1 here is equal to 5, because I already had this 1, 2, 3, 4, 5. Okay, I'm setting this 1 over here for a 7, that is 1. So 5 minus 4, 5 minus 1 will be 4, and then when I shift that 1, this 4 to here, it will be 1 here, right? And if I subtract 2 minus 1, okay, so I'll be getting all these 1, 1, 1s, right? So this will become 0 and this will be 1, 1, 1. Okay. So then if I OR this here, okay, so then I'm getting this value. Okay. So this value actually, if you look at it, so this will be F, okay, and this is 8. Okay. If you just compare this, right, this is F, this will be 8, and this will be 6, right? And this will be 3. Right? So this is 368F. So this is our actually the next higher one. And if you just quickly compare what I was showing here, okay. So see, it is 368F, right? So this is the next highest one. Okay. So this is the way it is done for the next higher one. And if we go for the next previous one, mm, uh, okay, let me go to my OneNote again. Okay, so in the next previous one, what they say is, you again do the same thing. So you find a pattern like this. The one which has, in this case, we need to find something which is 1 and 0 blocks. Okay, so it is like we first find a pattern of 1 and then all the number of zeros. Okay, so what we need to do is we need to actually uh, reset this one, okay, which actually finishes with all the zeros. So first find all the ones and then the zero block. So in this case, my C0 is 5 because there are 5 zeros, and as C1 is 2. Okay. So then what I'm going to do is the 7th bit actually, which is set to 1, I'll be resetting this to 0. Okay. So this what I do, and rest of all the bits are again cleared, which are on the right side. Okay. And then now when I'm cleared with this, so I know that I have to set 3 bits which are to the uh, right side of this 7th bit. Okay. So in the previous one, what we are doing is we were actually, for the next greater one, we are pushing all the 1 bits to the extreme right side. But in this case, we cannot push that because that will be a very lower number, right? So what we need to do is we need to actually place all our 3 bits just after the place where we set 0. Okay, so this way, like this. Okay, so for that they actually do this mask. Okay, so it is the masking again. Here you take A0 inversion of 0, it will be all FFF, and then you actually move all of them to the right side by P plus 1, right? And then you add with that. So you will be actually resetting all the values from here. Okay, because they are all zeros, right? So if you have
Uh,
set to here,
Hi, Santosh.
Yeah, go ahead. Yeah.
So you said to put three ones, but is that making equal number of ones because we are removing two ones on the right side and we are adding three ones to make it small?
Well, okay. See, we have two ones, right? So these are the two ones earlier, and then we have five zeros, correct? One, two, three, four.
Yeah.
So what we are doing is the seventh bit, which was already one here, I'm actually resetting
Okay.
to zero.
Okay. Okay. Yeah.
So yeah, if I set to zero, then I have three bits to set, and then I
Mm-hmm.
just go here and the immediate bit after which I set to zero, I set all of these to one, one, one.
Okay.
So
Yeah.
as simple as that. So only this masking is slightly a weird way of doing it, but yeah. So and therefore that's more confusing. Okay. So in this case, if we say take any number and then invert to zero, so you'll get all FFs, right? Right. So if you get all FFs, and then what we are trying to do is we are trying to right shift it to P plus one. So P in this case is 7, which we are adding C1 and C zeros. So that is 1 plus 7 plus 1 will be 8. So we will be setting one bit somewhere here. Okay, so that will be 1. So when we push all of this, so what we are doing is actually we are pushing our mask over here, somewhere here. So rest of these 1, 2, 3, all of these will be FF, zero zeros, right? And then this all will be Fs, right? So if we have all these zeros and then we add this, so the all of them will become zero, including the seventh bit. So that is what he's trying to do here. Okay, and then if we if we go down, then the way actually we need to set the ones which are these ones bit, right, immediately after that. And to do that, uh, so to do this again, we have to form a mask of C1. So C1 in this case is only 2, right? So 2 plus 1 will be 3. Okay, so then we are going to set C1 is 2, 2 plus 1, 3. So we shift it to 3 positions. Okay, and then we subtract 1 from it. Okay, so then we subtract 1 from it. And yeah, so that is 1. And then we need to actually shift C0, C0 minus 1. So in that case, C0 is 5, right, in our case. So because we have to shift all of them to this position, right? Okay, let me see what another thing has happened here. So we get here. Okay, so 0 is 1 and then we set to 1. So C will be here, right? Okay. Okay, C is 2. So if I set 2 plus 1, so in this case it will come here. So it will be 3, and then I'm shifting to one position, it will be somewhere here. Okay, and then okay, so 1, 2, 3. Okay, and then subtract 3 from 1 will be 2, and then I shift those two. Okay, C0. So again, I have to shift with C0, which will be 5 minus 1. So I have to shift all of these to 0, 1, 2, 3, 4, right? So therefore, these will be set over here. Okay, so we have C1, which is 2 plus 1, 3. So these are the 3 bits. Okay, and then I'm shifting to 1. So it will come over here, right? 0, 1, 2 and 3, right? So this my 1 will be set here. Okay, and then I subtract 1 from here, so I will get 0, 1, 1, 1, right? So that is what it means here, A. Okay, so sorry, A minus 1. Okay, and then now what I have to do is I have to shift C0, which is 5, C0, which is 5, right? So 5 minus 1 will be 4. So if I shift all these 1, 1, 1 4 times, so then I'll have these all zeros, right? So we'll have 1, 2, 3, 4 zeros. And that is the reason it is like this. Okay, and then we actually OR with the N. which was actually earlier this value, right? So if we actually OR this with 1, 1, 1 and all these 4 zeros, so we get our answer. Okay. So
Yes,
I
sir.
will go to my code in that case. And if I go to my code, okay. So this is the way over here. Okay. So for the previous one, what I do is again, I count the zeros and one. Okay. So first year, I have to count the ones, one block, correct? And then the zeros. But in the previous one, we are doing it the reverse way. So we count all the ones first. Okay. Therefore, whatever the number here, I'm saving it here, and then I'm ORing it with, ending it with one. So till I get all the ones, I keep on shifting the temp to the right side, okay, and keep on increment my C1. And then if my temp is 0, it means that haven't found any one, okay, and all my number is 0, so it doesn't make sense. So I return -1 from here. And after ones are counted, then I count for zeros, okay. So now I have C0 and C1. So I have P, which I have to set. Okay. So the way I've set is actually if I add 1 to that P, in this case, 7 plus 1 will be 8. So I'm shifting to the 8 bit. Okay. And then when I do that, okay, then I actually, uh, so I don't shift it directly because I take a mask of 0. And if I do inversion of 0, so I'll get all FFs, right? So I shift all the FFs to the left side. So what I'm going to get is all zeros on the right side, right? So at least I'll get all the 8 bits zeros on the right side. Correct. So in this case, it is like my tilde 0 will be something value like, if it is a 32 bit, so it will be 1, 2, 3, 4, right? 1, 2, 3, 4. And then I shift this to 8 times. So what will happen here in this case, it will get converted to 0x, FF, right? FF, right? So this 2 FF and then 0, 0, right? So this is the way it will be shifted. Okay. Then when I've shifted that, then I actually add C1 to 1, right? So in that case, C1 was in this case, the C1 was 2 in our earlier one. So I add that. So it will be 3. And if I shift 1 to 3, it will be something like 0x 80, 10, right? So if I do, and if I subtract this from 1, so what I'm going to get is 0x 0 of f, correct?
Yeah.
No, it should be 7, sorry.
Yes.
7. So it should be 8 here. My bad here, right? So if it is 8, right, because we are shifting to the third bit only, right? So C1 is 2, 2 plus 1 will be 3. So if I shift it to right, okay, and then I shift it to right, so it will be 0, 8, okay, and then I subtract 1 from it, it will be 0, 7. And then when I'm done this 0, 7, I need to actually shift this with 4 bits right now. So if I have 0x7, 0x07, and then if I shift with 4 bits, okay, so if I shift with 0, so 4, so then what I get here is so whatever that will be 0x, if I shift to 7, and then it will be all zeros, and I think it will be 7, 0, right? And then if I add this over here, okay, because my n, whatever my n will be previous value, so then it will be ORing with that value, which will be 7, 0 in this case, right? Yeah.
Yeah.
Okay, so this was the whole example for the bit manipulation. Okay, and I have some examples here also. And, oh man, there's so many of them. Okay. Uh, okay, if I just go to the first one. So if I have something like this, okay. So if I have see 1004, okay, which is my n, and well, I have to look for my output, right? So the next number will be this one. Okay, so this is the one what we are seeing in the example 13984, and if I go for the next higher bit, it will be 13967. Okay, and for the previous one it was 10096. Okay, if I take this as an example, right? So this is the next higher number of 13948, 13967, and 10115, it is 10096. Okay, so this is the same as this one. Now what is said in the book again is, uh, if I go to this one, so they talk about another approach which is said as like an arithmetic approach. Okay, so this was more of a bit of manipulation. I hope this was clear, right? Or do you want me to actually go through it again? And because I also confused you guys a little bit here. So, but on a high level, it is clear, right? So, because whenever we want to find the previous number, it is very straightforward, though, if I explain it here, right? The only thing is about this bit masking and everything, right? So, if I have this number, right? So, what I have to do when I have to find the next higher number in this case, so I always count the zeros first, and then I count another block of ones first. Okay, so whatever the number comes in, which is C0 and C1, then I actually go and set that bit, 7th bit over here as 1, clear all of these. So now I know that I've set one bit. So we already have this 5 bits here, right, which were set, but I've already set one bit. So what is remaining is only 4 bits, right? So when I want to find any get next number, so if I have to have the values as same as the bits to be same as the original number, and I've left with all the 4 bits. So for the get next number, I should always put all my ones at the very extreme right side, right? So this is what for the get next number. So if you, on a high level, if you look at this way, so you can use any way you want your mask, right? So, but only thing is, we should actually first set the one bit over here in this case, and all the rest of the ones which are here. So yeah, this bit should be set to 1, and the remaining 4 bits actually should be pushed to the right side. Okay, so this is what we need to do for the get next. But for the previous number, what we have to find the lowest number in that case. So we
So
are
just
going
one
to, yeah.
second. Can you scroll up?
Mm-hmm.
So in the second block, so we have how many ones after 7? 2, 3, 4, 5 ones.
One. Okay.
Like we have 5 ones, and then
So this is our original
so
number.
we need to decrement one, and then like if we have 5 ones, we need to add 4 ones at the rightmost position, correct?
Right. Yeah. Yeah. Like this.
Okay, so we need to decrease one. Okay.
Yeah. So if you look at this original number, my 7 is 0, right? So I have a block of ones, which are 5. Okay. And then I have a block of 0, which is 0. So we should always look at this zeros and ones. Okay. So at the immediate 0th bit after all this one block, it says flip the rightmost non-trailing 0. So this is the rightmost non-trailing 0. Okay. Then you
Mhm.
set this to 1. Okay. And then you clear all these bits. So that is what we do here.
Yes.
Okay. So when we have set 1, we know that we are supposed to set 5. So we have already set 1. So we are remaining with only 4 bits now, right, in this one, because we have set this one. So we take this 4 bits and then we just add it to the very end at the right side of it. As simple as that.
Okay. Makes sense.
Yeah. So basically we take this 5 bits, we just push this 1 bit over here, and then just take all these 4 bits and then push it to the right side. And if we go for the previous one, if you want to see what is done in the the one which is to on this side. In that case, we do it almost the reverse way. So here, if we see, this is our original number. So we have all ones here, which are two ones, and then we have all these zeros. So what we need to do is we need to take this one, which is after the zeroth block, the first zeroth block, and then we have to reset this. So now we have reset this to 0. Okay. So now we know that we have already 2, and we are clear all the bits also here to zeros. So we know that this is 1 and this is 2, right? So we have actually 3 bits to set them again. So what we do is we don't set all the bits to the extreme right, because that will be the very lowest number. So we want to find the next lowest number than the current input number, right? So for that, what we do is when we have set a 0 over here, we just take all the 3 bits and set them immediately after the one which we have set to 0. So it should be immediately to the right of the 0 bit what we have set. In the previous one, we were setting all the ones bit which were to the extreme right side, because we are setting 1 over here, right? Now we are actually setting this 0. So the number actually is now becoming more lesser, right? Because if we set this 1 here, if we make this 1 to 0, we have already reduced the number to very low. Okay. So whatever the number of ones which are remaining, 1 bits which are remaining, we just have to put that to very close to our 0th bit. So therefore we get a next lowest number. Okay.
Can we do with some small example this thing, like a
Okay.
trailing, yeah, like any number which is
Okay. So if we
15
say
or
like this,
something.
so 0, 0, and if we have, if we take something like, okay, can you
Let's
suggest
say
any
15
number?
number we have. 15?
So just say 15, right? So if we have 15, so if we take only 8 bits here, right? So these are the, and then we have all these 4 ones, correct? So
Yes.
in this, what we are going to do, if you want to find the previous number,
Mm-hmm.
so now we have all these ones which they are 4, and the
Mm-hmm.
zeros are also 4, right? So okay, so now in this case, okay,
But
15
we
will be
don't have a
slightly different
trailing
example.
zero. We
Yeah,
don't have trailing zero over here.
yeah, that's fine. That can also work, but for our case, we'll take a trailing 0. So let us take
Okay.
14.
Okay.
Okay. So what will happen? 0, 0, 0, 0, and then we have 12, and then we have like this, right?
Yep.
So we have 0, C0 as 1, okay, and then we have C1 as 3,
Mm-hmm.
right? So now if we have like this, so we have P is equal to 4, right? So 4 means this bit, right? So we have all these. Okay, we don't have anything after this one, right? Okay. So in that case, what we can do here, um, okay, so this will be slightly interesting. Uh, okay, let us take once, then we can come to this case, because I want the pattern which are here like this, right? So we have something like 0, 0, 0, 1. Okay, and then I have something like 0, 0, 0, 1. Okay. So in this case, the number is, this is 16 and 7. 16 plus 7, what it will be? 23, right? So my number is 23, right? 16 and 7. Okay. So now I have 3 ones, and C1 is 3 and C0 is 1. Okay. So this is 4. So what I'm going to do is I'm going to reset the first bit over here to 0 in that case. So I will just make this all zeros. Okay. So now I've made this 0. So I know that I have already 3 ones and this 1 to set. Okay. So I just go and set all the 4 bits immediately after that. Right. So if I do this, this will be my 15 number. Okay. And then if I take this 23, and if I go look for its next lowest number, it will be 15, which has the same number of bits. Okay.
Okay.
So Okay, let me do it again. So if I have 0, 0, and then this was 0, 1, and then I had all these 1, 1, 1, right? So in this case, what I did was I just set this guy to 0. Okay. When I set this guy to 0, so I had already this 3 ones with me and then this one with me. So I had 4 bits. So I need to set all of the after the sorry all the bits. Okay, so I have to set all of them to 4. Okay, so I have to set all of these to 4. So if we take this as 23 and this will be 15. Right. So your example, the other one was 15, right? So in that case, it will be slightly different
So
because
you
we don't have.
provided the next, so in the 23 example, you provided the smallest 15.
Right. Yeah.
Okay.
Yeah. So if we go for the 15, it is slightly different because then we'll have to set the extreme one to it, right? Yeah. So even if I just quickly add it here, okay, 15, I go to this with manipulation and then I go for this one. Okay, for this 15, and if I see this one, yeah, the previous number will be -1 because we don't have anything to set after that, right? In the 15th one. Yeah, so actually can't find any of that. So the lowest one after 15, they are all ones. Yeah. So that is a corner case. Yeah. So if we take something like 14 or so, then it might be we might be able to find that. So yeah, for 14 you can find a 13, but not the 15th one. So if we can do with 14, okay, so that might be slightly okay back here. Okay, if you want to find something for the okay, am I sharing this number? Okay, so you said 14, right? So if it is 14, it will be 0, 0, 0, 0, and then we had uh, 8, 4, 1, right? So this is 8, 4, 12, and 2, and 0, right? So this is 14,
Yes.
right?
Yes.
So in this case, what will happen is it will be like we will be setting this to 0. Okay. Now we have set this to 0, right? So because now in this case, we don't have any ones. So C1 is 0. C1 is 0 and C0 is 1, right? So C0 and now P is also equal to 1. So C0 plus this because 0 plus 1 will be 1. So P will be 1. So now what we'll have to do is I'll have to reset this bit. Okay, when I actually right shift this P to here. So I'll be
So where is
resetting this
P?
bit.
So why P over at 1? Like we have two ones.
Yeah. So always we need to look like this. We have to find a pattern like this. Okay. So the immediate trailing 0. Okay. After that, whatever one I have, I need to reset that. Okay. So I have to have a pattern like this always. So if I don't have ones, okay, if I have all zeros, then I just have to set whichever bit is after that to 1. I reset 1 after all the zeros to so here, so this is the way I'm finding here. Okay, so
Okay.
here I don't have. So now in this case, my C1 is 0, and C1 means the number of ones, right? To the
Okay, we
right
don't
side.
have one after that one. Yeah.
Right. Yeah. So after this 0, we don't have any one. So we have only 1 0. So therefore it is 1. So 0 plus 1 in this case, P will be 1, right?
Okay.
And therefore what I do is I go to year 1 and then I reset this guy. And now I know that I have left with only 1 to set. And this is the only position where I can set. And therefore my number becomes 13.
Okay, makes sense.
Yes, it's slightly confusing. Yeah. And yeah, the way they have used their mask as per their, yeah, this is also good, but it is very specific to the way they are using it. So now they have another way to do it is an arithmetic approach. Okay, so the arithmetic approach is the same thing. He says like you get a pth, the same thing what we were actually discussing. If you want to find a next number, you set the pth bit to 1, okay, and then all the bits following p you set to 0. Okay, so the way they're doing is like you have something like this, the number here. Okay, so if we have p in this case, if we take a smaller one instead of taking the bigger ones, now 0 0 0 0, and we have 0. So in this case we want to have 1 0, right? Yeah, so if I have something like this, okay, so in this case my C0 is 2 and C1 is equal to 2, right? So I want to find the get next number. So what he's saying is my pth bit, which is actually will be 4, set to 1. Okay, so how do I set that? So what he says in this case, what I need to do is C0 is 2. So 2 raised to 2, right? 2 raised to 2 will be 4. 4 minus 1 will be 3, right? So he's saying that you use 3. This is arithmetic, okay? So I just add 3. So if I add 3, what I'm going to get here is 0, 0, 0, 0, 0, and all 1, 1, 1, 1, right? So when I get this, so I'm getting here 1. And then if I add 1 to this now, this number, so what I'm going to do, this will be 0, this will be 0, this will be 0, this will be 0, and this will be 1. So this is a different way of actually setting the pth bit. Earlier we were doing a bit manipulation, and this is now a arithmetic way of doing it. So you take a number, okay, then whatever your C0 is, you know, you square it to 2 raised to that number C0. So that will be like, this will be 4 minus 1 will be 3. So if you add 3 to our n in this case and add after 1 to that, so I'll be setting automatically this bit, right? So if I do it again, so if I have something like the 0 0 1 1 1 0 0, so this is 12, right? So now what is saying, I have all C0s to 2 and C1 also to 2. So now what he says in this case is 2 raised to 0. So 2 raised to 2, because I'm taking this one, right? See, so this is 4, okay? And then I subtract 1 from it, it will be 3, okay? So what is saying now, if you add 12 plus 3, okay? So what I'm getting is 15, okay? But actually I want to set this bit. So how do I do that? If I add now 15 plus 1, which will be 16, right? So 16th bit representation is like this: 0 0 0 1 0 0 0 0, right? So I have automatically set this one bit, just doing the mathematical way, right? This is not a bit manipulation. You got it?
Yeah.
Okay. So if the first thing always is like we have to set pth bit to 1. Okay, in this case we have set this to 1, and then we have to actually set whatever the bits 0. Okay, C1 minus 2 to all ones. So C1 minus 1 actually, not 2. Okay, C1 minus 2 to 2. So because now what we have done is we have set this one bit over here. So we have remaining with another one bit which we'll have to set it over here, right? So we just take to whatever are 2 raised to, in this case C1 is 2, right? 2 minus 1 will be 1. Okay, so which will be 2. Okay, and then if I subtract 2 from 1, so I'll have 1, right? So then if I add the 16, okay, plus 1 will be 17, right? So now my binary representation of 17 will be 0, 0, 0, 1, 0, 0, 0, 1, right? So this is the 17 and this is the next highest number, right? If with the same bits. I did the same thing with the arithmetic approach. So what I did is I moved this one bit over here, right? So here, and then this one bit, I'm just pushing it to the extreme right. But this time I didn't use any bit manipulations or the masking and everything, but I'm using this formula for actually setting all the bits. Okay. And now if you look at, if we actually simplify this, so this is the way it is done here. So he says that if you want to find next higher one, so if you say n plus the same thing, what he is repeating here is power of, it will be like if we have the original number as n plus 2 raised to c0, okay, and then if you minus of that with 1, and then if we add 1, right, so this is exactly what we are doing there, right, and then if we have this 2 raised to c1 minus 1, okay, and then again we subtract 1 from that, and if we evaluate this whole function, what we get is n is equal to 2 raised to c0 plus 2 raised to c1 minus 1. So this is what we get. And then if you want to find these two, and we can just do a left shift. So if we can say n plus 1, which is the original number, and if we just shift to c0, right? If we do a left shift, right? And then if I add again a left shift of this number c1 minus 1, right? And then I subtract all of this by minus 1. So this is the formula. And if you can use this, so we don't have to do all these complex things as well as the bit manipulation. So this becomes a very simple formula. Okay, so I will just quickly show you the code also for this. Yeah. Okay, so if you see in this case, we are actually counting the C's, C0s and C1s, okay? And then if you just put that in this formula, we'll get the next higher number, okay? So this is not very straightforward to come up with, but if you actually look at the way they have said, right? So you take a number, then you take all the C0s and then you raise to that power and all that stuff. And then if you evaluate this, you get this formula. So they're trying to say how you can actually do it, but coming to this will not be a straightforward solution, right?
Yeah.
Okay, so this was one. And then if you go for the previous one is also almost the same thing. But again, it is boils down to this formula. Okay, so if you want to take an example here, okay, let me go for this one quickly. If you want to take some example, if I 0, 0, 0, 1, right? If I want to take, okay, let me go on first, run this 14, right? We had that 0. Sorry, let me fix my mic first. Just give me a second. Am I audible now? Yeah. Okay. Can you hear me?
Yeah, you're right.
Okay. Can you hear me, Nishan?
It's very low. Your voice is very low.
So can you hear me now?
Yeah, now it's a little bit audible.
a 1. Okay. So for the previous one,
Your audio is not audible.
Yeah, it's very low. I mean,
Very, yeah, it's very feeble. The earlier one was fine.
yeah.
okay.
No more. I think you'll have to increase
Is it more or low?
More.
more.
Now it is okay.
Or it's less. I mean, you increase your volume.
Okay. So is this okay now?
Yeah, now it's fine.
Okay. 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 So for this one actually, okay, let me stop the sharing. But if we go here, now it's coming to this one node, right? Yeah. So in this case, if I take a 14, right, and if I do for this one, so if I take 0, 0, 0, 0, right, and then if I take 14, 1, okay, let me take this number, right, 0, 0, 0, 0, and then I have 1, 1, 1, 0, right? So the next greater for next lower for 14 will be 1, 0, 1, 1, right? Okay.
Yeah.
So this is 14 and this is 10, 11, 12, 13, right? So this is the lowest one. So in this case, what he's saying now, if we look at this one, our C0, okay, so we have to look for a pattern like this, right? To get the previous number, we have to look for, now in this case, C1 is equal to 0 and C0 is equal to 1. Okay. So if we go via this mathematic representation, now this is our n. Okay. N is equal to 14 and 2 raised to C1 in this case. So if I just go by this first formula, so n minus of equal to 2 raised to C1, which is 0 and minus 1. So 2 raised to 0 is 1. 1 minus 1 will be 0. So I don't do anything here. Okay. So then when I'm, so my n is actually 14, right? So n still remains 14 and then I subtract 1 from it. Okay. So then I
Yeah.
subtract 1 from it, then I'm going to get, actually this value will be 13. Right. So actually this value becomes 13, and then if I again I have to do actually for the C0 bit, right? So in this case my C0 is 1, right? So if I say like 2 raised to C0 minus 1, which will be 0 again, okay, and then minus 1. So this will be 1 minus 1. This also will remain 0. So this won't have any impact on this, right? N minus 1 is equal to, this will be 2 raised to 0 minus 1. Okay. So my answer still remains 13. Okay. So for this was for the previous one. Okay. So this is one about, and the last one in this bit manipulation, it says like if you have a monochrome, this is the example. If you want to draw a line, okay, on a monochrome screen, and is stored as a single array of bytes. That is what say the monochrome screen is stored as a single array of bytes, allowing 8 consecutive pixels to be stored in 1 byte. Okay, and the screen has a width W, okay, which is divisible by always by 8. That is, no byte will be split across rows. Okay, and the height of the screen, of course, will be derived from the length of the array and width. And then they are asking us to implement a function, okay, that draws a horizontal line from x1y to x2y. Okay, so in this case, y is constant. It is same for both of them, but we have x1 and x2. So it will be a horizontal line that we need to draw. And so this will be our method signature. So I have a draw line, then this is my screen. It is a byte array. Okay, and then I'll have a width set. Okay, and then this will be my integer x1 and integer x2, and this will be my y coordinate. So if you have to do this, okay, so this is actually just one way of showing how we can set in a graphics mode, right? So but the bit manipulations for this, okay, I actually need to shift to the next screen. Okay, so this is visible, right? The next screen.
Yeah.
So this is my function, okay, and this is my screen, which is my byte is of 8 bits, and when I'm giving a width x and x1, x2, and y. So here actually it just shows how we can do bit manipulation here. So that is what the whole some problem is about. Okay, so what it says here, actually you first find a start offset. Okay, now I've taken an example here. So my screen size, this is my screen, right? My screen is a bit like 80 by 64, and I'm setting all of them to zeros. Okay, so width of each and every uh, width of my screen is 80. So it is 80 into 640, something like that. So then I start from 19 to 72, and I'm starting on Y, which is 2. So I'm starting on the 0, 1, 2 line, third line almost. And then in the third line, I'm starting from the 19th location to the 72nd location. And my screen width is always 80. Okay. So if I have to do that, in that case, how do I actually uh, convert all of these numbers into my bit manipulation, right? So first what I need to do is, because my this screen actually is always in bytes, it's an array of bytes, that is what it says, right? So I need to find a start offset, okay, and then end offset, because my y is going to remain same, so I don't have to bother that. So in this case I have just x and y. So if I just find the y of x offset first, what I do is I take x1 and then do a modulo by 8, right? So in this case, if I take this example, exactly what is shown here, okay, so I just take this. Okay, so now this is my x1, right? 19. So 19 modulo of 8 will be how much? So if I do 19 modulo of 8,
11.
sorry?
11 it will be.
No, modulo of 8, right? So 8 1 8 2 is 16. So it will be 3, right?
Yeah,
Right?
sorry, I agree.
So this will be 3. And now in this case, if I divide x1 by 8, it will be 8 to the 16, right?
Yeah.
Okay, so this will be my first full byte. But it says now if my start offset is 0, is not 0, okay, so then he says my first full byte actually will be +1, right? So my first full byte now will be 3. It won't be 2, right? Because if you look at the way we do here, right? So if we have 3 bytes in this case, right? This is 1 byte, this is 2 byte, and this is the third byte. So 1, 2, and 3. So we have 8 bits here, right? So this will be 0 to 7, right? And this will be 8 to 16, and this will be 17 to
24.
23,
3. Okay.
right? 23. So now my 19 lies in here, correct? So it will be 16, 17, 18, 19, somewhere here, right? So this starts from 17, right? So this is going to be here. So therefore, my next full byte actually will be after this. So my next full byte will be 3. Got it? So this is the first full byte. So if I have to do something, if I have to start, so now my next full byte therefore is going to be 3. Okay. Had it this guy been 0, the modulo of x1, okay, now it is not, it is 3. So actually the third bit is actually set to that value, right? So if had this been 0, so then I would have taken from here itself, right? So I would also have to add all ones to this byte. Okay, so the function actually what it does is actually goes through all these bytes, all these byte location. Like I have 80 bytes on a single row, right? So in this case, I need to find where is my 19th location lying, and the second one is like where is my 72nd lying. So 72nd will be at a very far away, right? So it might be located at some byte. So from this byte, I have to actually put FFF here, keep on putting FFF, all of these, right? Till my 72nd appears. But in this case, I cannot put all of, in this one, third byte, I cannot put all FF. So what I need to do is I need to only put the last 3 bits, right? Oh, sorry, last 5 bits to 1. So in that case, it will be the byte representation will be 0x1f, right? So that this will be my uh, what you say. I'll have to fill this value 0x1f in the second bit, and rest will be FFF, right? Till my 72nd doesn't come here. 72nd is the x2. Okay, so that is what we are trying to do in this case. So now, therefore, we have found here. Uh, so we have found this x is 3. Okay, the start offset, and this offset actually now we know it is going to be 3, right? So the first full byte will be 3. So that is what we calculated here. So same thing if we do for y offset, that is the end side. Now in this case, what we have 72 modulo of 8. So what is that going to be?
0.
Is 8 actually 72 is always divisible by 8, right?
Yeah.
Okay, let me quickly see it here again. 72. Oh, I should have taken the scientific one, right? Yeah. Okay, 72. And if I divide that by 8, right? So this will be what I'm doing. Okay, so if I do 72 divided by 8, okay, so this is going to be, this will be an exact division, correct?
Yeah.
Okay, so in this case, my end offset will be 0. This is fine. But then if I go here, this is going to be 9, right? So last full byte will be 9. And then this is actually is not equal to 7, right? Therefore, we cannot decrement to 1. So actually this will be the 9th byte. Okay, the last byte will remain the same, right? So what it says is, now what we need to do here, if we have like this, the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So this is 0 byte 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So he's saying that from the third byte, right, from this onwards till this 9th byte, okay, so I need to put all these FF values in all of these bytes, okay, all of them. So from F3 to 9. Okay, so this is what I do. And then only on the second bit, and the second byte, where I have the start offset, okay, so I need to actually just leave all these first 3 bits, right, the 3 bits. So last 5 bits, actually I have to put 1, 1, 1 in all of them, all the 5. So that is going to be 0x1f. Okay, so this represents a line, a complete line. Okay, so that is what he is doing. And then the way it has to be done here, first you calculate all these offsets. Okay, the first full byte offset, and then the last full byte. Okay, and then this is a screen, this is the 2D 2D vector here, right? So that is what the screen is, vector byte. So sorry, it is single 1D vector of byte variable, right? So then what has to be done is, in that you need to find the width. Okay, so width is given as 80 divided by 8, and then you multiply by y in this case is 2. So whatever that value, and then we start actually filling all these, start from this first full byte, what we calculated over here, to that last byte. So I'm just putting in 0xFF, but only when it comes to the mask part. Okay, so now I have to form a start mask in this case. So he says that you take a 0xFF because it's only 8 byte. Okay, and then you shift that to the right side. So right side you need to shift by, in our start of side it was 3, right? So if we shift it to the 3, so our 0xFF, it will be converted to 0x3f, right?
Yeah.
Because we are actually making the first 2 bits, it is going to be shifted 3, right? So it should be 1f, sorry. Okay, so it will be 1f in this case. And for the end offset, we don't have anything, right? So even if we have 0xFF, okay, and the end offset was 0 plus 1, okay, and then if we shift 0 plus 1, so if we even shift by 1 byte, it will be something like 0x7f, okay, and then we actually add that. Should not actually, right? We should not be able to shift anything because our n mass is 0. Okay, so why is that one there? Okay. If I shift this to 1, it will be 0, and then okay, so it should be again 0. But anyway, I'm not going to have any byte mask here. But yeah, I'm sorry about this. Yeah, there's something problem here. Should not actually do 1 plus 1, right?
Yeah,
Yeah,
that
I don't know.
extra.
But even if I do here, let me check what my statement says. Yeah, in this, okay. If I say this 80, so I'm starting with a full byte is at 22. So these are my full bytes, right?
Yeah.
Yeah, this is the full byte. So I actually am doing from 23, 24, 25, 26 full byte, and okay, this is my width actually. I'm putting that. That's fine. So 3, 4, 5, 6, 7, 8, and my start mask is 22, which will be 31. Right, so if I have this 31, okay, if I have 31, yeah, this will be 1f, and my end mask actually is 128. 128. Okay, it is 80. Okay, end mask. Yeah, so because that is the last bit I have to set, right? So, yeah. So even if I have this, because this 72 will be 1 bit more, right? Because that is what the byte starts from, right? So there is 1 bit to be set in that case. That is correct, right? So we have to set that 1 bit, and that is the reason we have to have 1, right? Because 70, because it all bits start from 0 to 7, correct? So the 9th bit will start from 72. 72 will be the first bit, correct? Therefore, it says that I have to have this 0x7, but then I have to actually invert it because I'm going to set the bit at the MSB side, right? So it will be 0x80. Okay. So 0x80 is 128. Okay. So this is what it is. Now, if I have this byte mask, and if my x1 and x2 are of the same byte, okay, I just have to do ANDing of both the masks. Okay, and then I set, because it will be a single byte that I have to set, right? In this case, like the second one, example, second one I'm taking like 30 and 38. So they belong to a single byte, right? So in that case, I'll come to this. So there will be 2 cases. One is if I have to set only 1 byte, or in this case, in the first one, I'm setting about these 1, 2, 3, 6 bytes, and then The one which is to the start and one is to end. It's 8 bytes, right? Totally. So this is what will be my second case, first case actually, and this is going to be my second case. Sorry, right? So if my start offset is not equal to 0, and if my this end offset is not equal to 7, in that case, these are the two things I have to change. Okay, yeah. So this was the one. Oh, sorry, we are already crossed the timing.
Yeah.
Sorry about it.
Yeah.
Yeah.
No problem.
Okay, I'll stop the recording.